Good day everyone. One of the main points to consider in the drone frame is the positioning of the mounting points for the various payloads and motors on the frame. It is important that all of it is done carefully. In our today's lecture, we will be looking at the details of mounting the payloads on the drone as well as the various components on the drone. The drone frame has three parts: a top plate, a bottom plate, and the arms. The top plate is normally thinner and often has holes for cable tie and battery straps. Also, people attach GoPro mounts either by top plate with screws or Velcro straps. The bottom plate is normally the thickest part of the frame. It is designed to soak up the crash impact. It also has the holes to fit the standoff for all your electronics. The arms may or may not be the part of the bottom plate. They hold the motors and sometimes the ESCs. They are either part of the frame or removable. Although a drone is far simpler to design and build than a normal helicopter, there are still enough parts to think about, and how to mount them should be considered early in the design process. Some general points to consider regarding mounting based largely on experience include: if you plan to create a custom frame, one of the more difficult mounting areas is between the motors and the frame, as the four mounting holes need to be placed drilled precisely. Most motors for 400 to 600 frames have the same mounting hole pattern, making it possible to use a frame from one manufacturer and the motors from the other. The placement of all additional components should ideally be symmetric about one axis, which helps facilitate locating and adjusting the aircraft center of mass. The flight controller should ideally be located at the center of the circle connecting all the motors, such, and as such at the center of mass. A flight controller is normally fixed to the frame using standoffs, rubber dampeners, or double-sided tape. Many companies seem to use similar mounting hole locations for the flight controller, but there is no industry standard. The battery is heavy enough such that if your center of mass is off by a bit, you can move the battery slightly to adjust it. Ensure the battery's mounting has a bit of a play, but still ensures it holds the battery firmly. Velcro straps are often used to secure the battery, and consider adding adhesive backed Velcro to the battery and frame as well. Let's look at further details about the motor camera also in the next couple of slides. One of the most important characteristics for the smaller planes is the motor mount. Will the frame be able to support the motor size you have chosen? Certain frames might also offer changes to the mounting of your motors. Typically, if a frame advertises titled motors, it means they are mounted at a 10-degree incline. Some frame kits might offer motor dampening to reduce the amount of vibrations produced, smoothing out your PIDs as mentioned earlier. You have to make sure the motor is mounted properly on the frame, else it might damage the frame in the flight or get detached from the frame in flight. It is crucial that you look for any cracks or bends near the motor mounts so that there is no sudden failure of the mount. Another thing to look out for is the type of camera you can use with the frame, as some frames are only compatible with certain cameras. These cameras normally include usually a dedicated part of the frame or a mounting blanket, which will be included in the kits. You also want to know what tilt you can achieve on the frame. Otherwise, you may be limited to a certain speed. As you may be aware, the camera angle allows to have a greater effect on your pitch. So this is quite an important factor to look out for. If it does not tilt high enough, you'll spend most of your flight staring at the ground when tilted forward. It is also worth looking at how well protected and closed the FPV camera will be in the event of a crash, as some frames offer no protection for the camera at all. To summarize the lecture, we looked at the mounting pattern of the frame and the various things we have to keep in mind while mounting the motors, cameras, and different components of the frame. In the next lecture, we will look at using CAD and rapid prototyping techniques to design the frame of the drone. Thank you very much.